We produce FMCs for high-speed serial connectivity and support them with a portable family of reference designs. We chose Xilinx development boards for this task. Here's how it's done. I am John McCaskill with Faster Technology. We are a Xilinx Alliance partner, an authorized training provider, and a manufacturer of FMCs. The FMC, or FPGA mezzanine card standard, is also known as VITA57. It takes advantage of FPGA's power and flexibility to allow FMCs to provide a variety of ready-to-use I/O solutions that may be used with both standard and custom FPGA carrier cards. For our FMCs, we produced reference designs for the Xilinx Virtex 6 ML605 development card. We were able to quickly and easily migrate these designs to both the Kintex 7 KC705 and Virtex 7 VC707 cards due to the flexibility of FPGAs and FMCs. This ML605 reference design for our Quad SFP FMC contains several ChipScope Pro cores. An IBERT core is used to instantiate and exercise the 4 MGTs. A virtual I/O core allows the user to sense and drive control and status lines to the FMC. Top-level HDL code connects the core to the pins of the FPGA, and the user constraint files specify pinouts and timing constraints. Finally, a Xilinx EDK Processor Subsystem has a microblaze running example code to communicate with devices on the FMC. Providing this reference design enables customers to run an example right out of the box demonstrating the key components of the FPGA, and to use this as a known good starting point to create their own designs, reusing as much of it as they wish. Next, we migrated this design to the Kintex 7 and Virtex 7 boards, a process which is straightforward. After creating a new project and adding the existing HDL code, we run Core Generator to recreate the ChipScope cores for the new target FPGA. The IBERT core is slightly different to account for the newer versions of the MGTs. We adjust the HDL code accordingly. The other cores use the same parameters. Next, we add an EDK subsystem and use EDK's base system builder to quickly create the processor subsystem with the appropriate versions of the various peripherals for the target FPGA. After adjusting pin locations in the UCF files, we build the design, export it to SDK, and build the software. We now have a finished design and are ready to download the design to our development card and watch it in action. ChipScope queries the FPGA over the JTAG connection. It detects the ChipScope cores we instantiated in our design, as well as the system monitor that is always present and available to ChipScope. The IBERT console displays the status of the MGTs, and the system monitor console displays the die temperature and internal voltages. We repeat these steps to port the reference design to the VC707, in this case modifying the IBERT core to use more MGTs. Here we see all 8 lanes running at the 10 gigabit Ethernet speeds. We have now seen the same reference design move from the ML605 to the KC705 and the VC707. We have seen that IBERT allows us to quickly see the MGTs working in a real design and explore their parameters. The EDK subsystem demonstrates how to use software on an embedded processor to control the FMCs. Having a working reference design allows our customers to use it as a starting point for their designs. Thank you for watching this demonstration, and be sure to check out our other videos for both the VC707 and the KC705 using several of our FMCs, as well as more in-depth tutorials on how to use the tools and IP cores that we use for our designs.